This project is an overview of the optimization of heavy press department at IGS Industries. It was completed as a senior design project for IE 1090 during the fall of 2016. The group members include Brittany Byrne, Toby Fiala, Eric Friend, and Tim Pan. IGS is a 150,000 square feet manufacturing facility that produces customer metal and rubber parts for various companies on a global scale. It is headquartered in Meadowlands, Pennsylvania, which is 25 south of Pittsburgh. Our project sponsor was Tony Mounts, the supervisor of heavy press department, was very eager to help our group and is the leader of all 5S implementation at IGS. Because IGS is a small manufacturing company that are always looking for new ways to improve in order to stay competitive. Our problem statement encompasses the non-linked scheduling and operations completed at IGS. The combination of outdata, lead time, and operating efficiency when locating tools and material causes unsystematic production processes. This leads to faults in production process and cause order to sit idle after the necessary manufacturing steps have been taken in the heavy press department.
We wanted to create the heavy press department as a model for all other departments in the company. In order to create a model department, our team completed various tasks involving machine capacities, a department-wide 5S plan, and organization of the interchangeable dies. For machine capacities, we conducted time studies on each machine, capturing the setup time, run time, and teardown time during both first and second shifts. For 5S implementations, IGS labeled all of the machines and the carts associated with incoming materials. Our team organized and labeled the tool carts to create the best setup. Visual cues, including shadow boards and labels, will be implemented for all hand tools that are on the carts. For interchangeable dies, we first recorded the size of all of the outer diameter dies presently used and their locations. We then labeled the outer diameter rack smallest to largest to ensure accountability in the storage area. Our main model was the optimal department that we were trying to create within the heavy press department. This model includes physical, technical, and numerical aspects in it and was developed to the greatest efficiency possible. Our other models include a layout of the entire department, workstation tool carts, the interchangeable die rack storage, and the machine selection and capacity tool. For results, we collected the information from our time studies and calculated what we believe is the most accurate setup and run time for each machine. Using these calculated machine capacities, we created a machine selection and capacity tool. This tool works by the user entering the material thickness, outer diameter, inner diameter, and percentage of maximum capacity. They then select material and job type, and the tool determines the correct tonnage needed and the press which it should be manufactured on. We then compiled a random sample of 20 jobs from the last year and determined various statistics from them. We concluded that 75% of runtime costs would be reduced using the correct machine capacities for our selected jobs. The remaining 25% of runtime costs would be increased. We also calculated 70% of the setup costs would be reduced using the correct setup times from our selected jobs. The remaining 30% of setup times would be increased. Both overestimating and underestimating setup and run times hurts IGS from a business standpoint. Overestimated times mean the company is losing efficient hours, which can lead to scheduling issues. Underestimated times mean the company promised lead time they are unable to fulfill. This can hurt their customer relations. Both of these affect scheduling due to machine availabilities. First, we created a layout of the entire heavy press department to ensure accountability of every machine, cart, scrap bin, and island department, and this can be utilized for further 5S implementations. For measured improvement, we look at the 5S plan in actions. We implemented the parts of the plan that we thought would have the greatest impact on the department. We then completed labeling of the tool carts and the suggestion of pegboards for holding hand tools. Next, using a proper 5S form, an average score of 0.77 was initially calculated by our team. If IGS were to implement all of our recommendations, we calculated that they would achieve a theoretical score of 3.4, meaning their score would go up by 2.63. The entire process of creating an optimal department was documented for future use at IGS. The methods and procedures that the team completed are to be implemented in the various other departments at IGS so that they can be optimized as well. Having the process carefully documented means that the same steps are taken for every department and the metrics and tools are consistent across all departments. We would like to acknowledge all of those who helped us throughout the project. These people include Tony Mounts, Lisa Vagrinovich, Dave Spar, Eric McDonald, and Dr. Sacre.